Good evening, Math Dragons. I'm here with you to do the practice greatest common factor. So this should be inside your awesome interactive math notebook. It is page 10. If you've been keeping up with us, page 10 lands on the right-hand side. So I've already glued this in for us, and I want to get started right away. So you already have a couple strategies on how to do the greatest common factor. One that we have in our notebook is back on page 9, where you can use the rainbows. But we also learned how to find greatest common factor using prime factorization, and we'll put more notes in our book about that later. Let's see if we can attack these problems. Aaliyah is preparing for her 12th birthday. She wants to hand out party bags to her guests, and she has purchased 2 types of party favors for the occasion: 24 ring pops and 18 candy bracelets. She wants to make sure that each bag contains an equal quantity of each party favor. Number 1, how many bags can Aaliyah make for her guests? Well, they haven't told us how many guests Aaliyah has invited, but we do know that she wants to do an equal sharing of the ring pops and the candy bracelets. Now, we've worked on this style of problem before, and it was called beads, beads, beads. And many of you wanted to add the quantities together and then divide, but we didn't know what to divide by. Well, let's think about other ways to work this. She wants to make sure that each bag contains an equal quantity of each party favor. How many bags can Aaliyah make for her guests? Well, we could make fewer bags. But what are the most bags? What are the most bags she can make? And we'll clarify that question because it should be, what are the most bags can Aaliyah make? She has 24 and 18. Well, we can start with the 24. We can make a rainbow 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 doesn't work, and we're back at 6. Okay, we need some for 18, 1 and 18, 2 and 9, 3 and 6, not 4, not 5, we're back at 6. All right, we can draw a Venn diagram. Not too fancy. Okay, there's my rainbows if you missed them. Let's see, we've got, for over here, we're going to do the number 24, and for here, we're going to do the number 18. If you're wondering where I'm getting these steps from, I am following the steps from page 9. I don't want there to be any confusion. I'm trying to be as clear as I can. 1, 2, 3, 4, 6, 8, 12, 24. Let's see, that's 8. Yep, 8 of them. 18 over here. This is 1, 2, 3, 6, 9, 18. Now, I've got the factors of 20, the distinct factors. Remember that word? Distinct factors for 24 here, distinct factors for 18 here. In the middle, I'm going to put some common factors. They share 1. They share 2. They share 3. They don't share 4. They share 6. They don't share 8, 12, or 24. The biggest, the most bags she can make is 6. Technically, she could make 1 bag, 2 bags, 3 bags, or 6 bags. The most is 6 guest bags. What is the 6? The 6 is the GCF. GCF. How many ring pops and how many candy bracelets will be in each party bag? If we go with 6 bags, it's going to be 24 ring pops, 24 ring pops divided by 6 bags. So how many are we going to get in each bag? If you said 4, I think I'm going to agree with you. 4 ring pops. And then we also have the 18 candy bracelets. 18 candy bracelets. bracelets divided by 6 bags. How many are going to go in each bag? 3? 3 candy bracelets. So if we had 6 bags, let's just imagine this. Leah's got 6 bags. And we've got 4 ring pops inside each bag. Let's see if this makes sense. 4, 8, 12, 16, 20, 24 total ring pops. That does make sense. And then we pop in 3 candy bracelets in each bag. 3, 3, and 3. So that would be 3, 6, 9, 12, 15, 18. That makes sense. That's what each candy bag would look like. So there is Aaliyah's birthday party problem. Step 1, I made a factor rainbow. Step 2, I made a Venn diagram. I put the distinct factors of 24 on this side, the distinct factors of 18 on this side. Where the diagram crosses over, we put our common factors. How did I know to look for factors and not multiples? She wanted each bag to contain an equal quantity of each party favor. We're chopping here. We're not multiplying. So we talked about this in class. So it's like the ninja chopping. We're divvying it up. So after you put your common factors in the middle of your diagram, the largest one is the greatest number of bags she could make. Yes, she could have had 1 bag. Yes, she could have had 2. She could have had 3. But she wants to have as many bags as she can for her party. Then we divvy up how many ring pops went into each bag. Then we divvied up how many candy bracelets went into each bag. Here is a visual representation of those thoughts. Let's move on. Ella's baskets. Ella is creating thank you fruit baskets for the adults who will volunteer at Saturday's Harvest Day event. She wants to make sure each basket contains an equal quantity of each type of fruit. She has 24 bananas, 12 apples, and 18 oranges. How many different fruit baskets can she make so that each one has an equal number of each type of fruit? What is the greatest number of fruit baskets she could assemble so that each basket has an equal quantity of each type of fruit? How many bananas, apples, and oranges will be in each fruit basket if Ella decides to make the greatest number of fruit baskets? Now this one I feel is much more clear. But let's start off with how many fruit baskets can she make so that each one has an equal number of each type of fruit. If I make rainbows for 24, which seems familiar because we just did it, 2 and 12, 3 and 8, 4 and 6, and let's see, we need a rainbow for 12, 1 and 12, 2 and 6, 3 and 4, I'm out. And then I'm changing colors here so I can be consistent. Now we just did one for 18, but I'm going to redo it just to prove a point. 1 and 18, 2 and 9, 3 and 6, and I'm out. Okay, our Venn diagram actually has to have all 3. It'd have to be a common of all 3. So if you were imagining this, that would be where the distinct factors of 24, the distinct factors of 12, and then the triple crossover would be the distinct factors of 18. So who do they all have in common? Let's look at it from that perspective because my Venn diagram is super tiny. Okay, they all have 1. She could just make 1 basket. They all have 2. She could make 2 baskets that worked. They all have 3. She could make 3 baskets that work. They don't all have 4. They don't have 5. They all have 6. She could make 6 baskets. They don't all have 8 or 9 or 10 or 11 or 12. You kind of want 12 there, but it's not happening. And then after that, we just get bigger and bigger. So she could make 1, 2, 3, or 6 baskets if she so chose to do so. So the common factors are 1, 2, 3, and 6. I'm going to circle that so you can see a little bit better. Those are the common factors. Now, what is the greatest number of fruit baskets she could assemble? Which one was the greatest? The greatest number makes us think greatest common factor. The greatest number that would contain an equal amount of each type of fruit would be 6 baskets. What's great about this one is you already did all the work up here. It's already complete. Now, if she goes with 6 baskets, as our GCF here, how many bananas, apples, and oranges will be in each fruit basket? We got 24 bananas divided by 6 baskets. We have 12 apples divided by 6 baskets. And I have 18 oranges divided by 6 baskets. 24 divided by 6 would be 4 bananas in each basket. 12 divided by 6 would mean we've got 2 apples in each basket. And 18 divided by 6 equals 3 oranges in each basket. Each basket contains a total of 9 pieces of fruit. 4, 5, 6, 7, 8, 9. 9 total pieces of fruit. And you could draw a pictorial representation just as we did with Aaliyah's birthday bags. If you wanted, you could draw 6 baskets with 4 bananas, because 4 times 6 would be 24 total bananas. 2 apples each basket. 2 times 6 baskets is 12 apples. And 3 oranges. 3 times 6 is 18 oranges. Okay, Dragons, you have finished Interactive Notebook page 10. Thank you for your time.